So those of you guys don't remember what's implicit derivative, that means you have y is inside as argument. So like say if you have sine of y equal to x, that is time to use implicit derivative. If you have x squared y squared, then that's the time to use implicit derivative because not y equal to something. So if the y is inside the argument, which is in this case the natural log of y, it's not y by itself, it's not y equal to natural log of x, then I use explicit. Okay? So what we're going to do is we're going to write down the questions. We're going to say, hey, let's take care of this. X squared minus 3 ln of y plus y squared is equal to 10. Sheila, let me go over it. D to the dx of this. If I d to the dx, this is just going to be 2x minus 3. Now, what's the derivative of natural log of y? Well, y is not x, so it's not 1 over y. What is it, Will?
1 over dy. It's a 1 over y dy.
1 over y dy, so it's good. So, or y prime over y, that's a little bit better because you want a y prime essentially.
Okay.
Now, plus 2y dy dx, plus 2y y prime. I'm going to do y prime is equal to 0. Now, what we're going to do is isolate a y prime. So that means everything else doesn't have y prime is moving on the right hand side. So that's going to be negative 2x is equal to negative 3 y prime over y plus 2y y prime. You can factor out a y prime. That's equal to negative 3 over y plus 2y is equal to negative 2x. Now I can do y prime equal to negative 2x over negative 3 over y plus 2y. Now, here is not the answer for algebra. Algebra, you need to understand it need to be a simple fraction. And what you can do in simple fraction is look at all the denominator in a complex fraction. In this case, there is a one denominator, which is y. So what you can do is multiply top and bottom by y. That's going to be negative 2xy over negative 3 plus 2y squared. And that's my final answer for this case. That's implicit derivative for you. Now, it's something we've done before, but yeah, so this is the case that I meant to put in before question 12 because you thought it's finding equation tangent line. There was no x value, which is my fault. So that's why I go over it now. But you're going to have another question like this. Yes?
Are we going to have to put it in like the simple form?
Yes, simple fraction because the multiple choice on MCQ is actually always simple, never complex fraction. What I mean by complex fraction is you have fraction over fractions. So if you have 1/2 over 3, they're not going to show up like that. So it's 1/2 over 3, it's going to be 1 over 6. Then you're just going to cancel out, simplify to 1 over 6. That's called simple fraction, which is only numerator and denominator. And just because easier to think about those stuff. Now, next thing is I'm going to go over is, yesterday we going over certain questions. And yesterday we go over something like this. I'm just going to erase this part. It's going to be y equal to, so yesterday we go over something like this. X squared square root 1 minus x squared over x minus 4 to the 4th power. And we say, what do we do? Yes, Hong? You completely split it up. And that's why I know Asim's not paying attention. Because I did not mention a word about quotient rule yesterday. So, today's question are much the same. There's only one step difference. There is a minor difference between two questions. Today's question is y equal to x squared square root 1 minus x squared over x minus 4 to the 4th. today I don't have a natural log. And guess what people's gonna do? Quotient rule. And I won't even read it. I'm gonna tell you, I won't even read it. Even you got a right answer, I won't even read it. And just because the format is gonna say use natural log derivative, it's gonna be using logarithm differentiation to do this. If you do quotient rule, it's already started wrong feed. If you do quotient rule, guess what? You're gonna have to deal with quotient, product, and chain at the same time. This thing will be way more ugly than this. So what you're gonna do is, the only thing about this part is you can break up individual parts, right? You can say y equal to natural log of x squared plus 1/2, or we're gonna put a 2 in the side here, and 1/2 of natural log of 1 minus x squared, and then minus 4 natural log of x minus 4. Now I can take a derivative after that, so it'll be 2 over x plus this one's going to be negative x over 1 minus x squared, because the 2 and 2 is going to cancel out, and that's going to give you a negative, so this end up to be negative. And minus 4 times 1 over x minus 4. So that is the final answer for this one. What's the difference between this one and this one? What's the major difference? It doesn't have an ln. And then if you take a derivative, what do you have to do? Quotient, chain, and product. Because derivative of the numerator is a product. Derivative of the bottom is a chain. Derivative top and bottom is quotient. It's just a very massive ugliness. So what you can do is, you can do one step that's different. ln of y equal to ln of x squared 1 minus x squared over x minus 4 to the 4th. Now you find out this is the same problem as before. Now the only time is when you take a derivative of this, then you will get y prime over y, just like the implicit derivative. Does that make sense? Now that's equal to, we already know the derivative of this. Derivative of this is going to be what? 2 over x minus x over 1 minus x squared minus 4 over x minus 4, because we already did that earlier. You can do that again because of different questions. Now that's not dy dx. What do you have to do? Isolate the y prime. So y move to the other side. Can I just rewrite the questions? It's a lot of writing, trust me. But if you deal quotient and product, it's going to be way worse. Worse to a point, I don't even want to read it if you have right answer or not. But your answer is going to be like this. This one is the y. This one is the derivative of the right side. The only part is on the left side is going to be y prime over y, so you move y to the other side. And there you go. That's a natural log derivative for you. So even though the problem doesn't have a natural log, you can make a natural log happen. But so if something like, just say 1 minus x squared over x minus 4, quotient rule, right? Something massive, ugly like this, that you have to deal with multiple rules, guess what? Using natural log differentiation, your life's going to be saving. You're going to get a right answer. You're going to be happy. It's easy, because all you got to do is know your log rules. What time we get off here? 24. Okay. And this is probably the homework that you're gonna have today. Tomorrow we're gonna go to this one a little bit detail. So tomorrow we're gonna introduce you a function that is more interesting. So you've never seen this kind of function before. So function like this is gonna be the first time you've seen this. Is y equal to x to the x power. Now, can you guys think about what a graph look like? I don't want to take a derivative of this. I just want you to think about what would graph the x to the x power look like. You never learned this. I want to see, challenge yourself to think about what would a graph look like. Kind of look like exponential function.
Really exponential?
Yeah, it goes
Like that, like all the way.
Instead of like
What happens if you take a number to the power of a negative exponent? Oh, it becomes a fraction. Sorry. I had to think about it.
So does this make sense, first of all? Does this part make sense? You can accomplish your homework this part, right? The only part different is to natural log both sides, and the only part different is y prime over y. The only part is moving y to the other side, which is rewrite the original questions or original expression versus derivative natural log of original expressions. It turns out it's actually very interesting.
Because like all the negative, wouldn't they all be one if it's negative?
Kind of. I think you have pretty much a very good point of view. So, y equal to x to the x power. It doesn't look like a problem. It looks like something, and that's why it's gonna have this kind of situation: is y equal to x to the x power.
It's like a Nike swoosh.
And it's more swoosh than the Nike swoosh, I would say. But this is interesting though. This help you to answer the question, what is 0 to the 0 power is? Huh?
I see it right there.
It's 1. Good. It's going toward 1. So this is actually interesting because that's going to go toward 1. And there's a turnaround point here. It's harder to find out where that point turn around, but we're going to do that tomorrow.